Okay, now we move on to some of the branches of organic chemistry. Now, there are basically two branches of organic chemistry, which are what? Aliphatic and aromatic compounds. Remember it says, we have to state this one. There are many of them. That is when you enter into that deep, now we see cyclic and acyclic compounds. But we are not going deep now. Now you have to know two things. That is the aliphatic and aromatic compound. Let's write it down. Now the aliphatic and the aromatic. Now this is just simple. I'm not here to stress it. I'm here to give you a full understanding in which you're supposed to know. Now, we move on. Now, when you hear aliphatic compound, that's a compound that have open chain structure. Remember he says, that is aliphatic compound. Or it's a compound. It's an organic, not just a compound, but it's an organic compound. You must put that word. If you say aliphatic compound is a compound, that means you're wrong. So you must say that aliphatic compound is an organic compound that have an open chain structure. Example, that have, jot it down, that have an open chain structure. I'm not here to start writing everything. I'm here to explain. That is my main thing here. So you as a student, you have to know some of the things. So I'm not here to start writing most of the things. All these things are in your textbooks, but it's the ability of you to understand some of them. So when you say aliphatic compound, aliphatic means an organic compound that have an open chain structure, or it can have a ring structure, but that ring structure must not be what? Delocalized. It will not have a delocalized what or orbitals. Am I communicating now? Now, when you say open chain structure, this is aliphatic now. Aliphatic. This aliphatic now. Example, we have alkane series, alkene, alkanoid. All those things are open or straight chain. We call them, sometimes we usually call them straight chain. That is opening. Now watch. This is alkane now. You're opening it. It's the same thing. Or alkene, anyone. Why we call them open? Because if you watch, this carbon is here. There's still like branch chain. Doesn't have a branch chain there. So watch it. Did you see any branch chain there? That's it. It's an open chain. It will just be expanding. That's catenation now. This is where the catenation have been involved. Sorry. Remember making sense. So here now, alkene, all of them, they're openly. That is from the word open. All these things are all open. It's just like something that's all opened. Am I making sense now? That is open. Do you understand? So this aromatic now, when you hear about aromatic compounds, they are compounds that have sweet smell, or they are what? Non-localized orbitals. They cannot extend their adjacent of the orbitals that have electrons. When I mean orbitals that have an electron, they cannot exceed something like cyclo compound. Now, this aliphatic is also cyclo compound. Yes, something like cyclohexane, cyclopentane, cyclomethane is involved in aliphatic. But this one is just a closed chain, not an open chain again. We close it like benzene. Benzene is a closed chain. We close it. Toluene, phenol. We are still going to write it now. Now, let's write it now. Now, example. There are compounds that have sweet smell. Now, if you have been hearing about aroma, now, maybe you'll be somewhere now, you'll be hearing a sweet smell, you'll be like, where is that aroma coming from? Aroma means smell, that's sweet smell. Am I making sense? So you have to jot it down now. Note it. So watch now. So this is an aromatic compound. When someone says this is an aromatic compound, it means a sweet smell. Now, example, you have benzene, C, 6, H word 6. Let's structure it now. Now, uh like this, like this, like this, like this, and like this. That is one carbon, one carbon, one carbon, one carbon, one carbon, one carbon. That is 6 carbon groups. And what? Hydrogen, 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 hydrogen. Now, hydrogen. Now, if you leave this thing like this is not a what? A benzene. Unless you must put the limiting structure or the conical structure of benzene there, which is either you add 0, that is circle, or you can use this one, the limiting structure. In benzene rings, I will teach it, benzene, as a topic. We have benzene, Kekule principle, I state it. We have the limiting structure of benzene and the conical structure of benzene. So they are different, because I will not enter the. Just know that benzene is an aromatic compound in which benzene has a sweet smell. So jot it down. I'm not joking here. So let's move. Now watch. Now this is a benzene now because of the limiting structure you have added. If you remove this thing now, this is a cyclic compound in which if you start adding like cyclic compound now, like this thing now, 1, 2, 3, 4, 5, 6. This is a cyclohexane. Anytime you see this and this is a cyclic compound. When this is a benzene, but this benzene is in conical structure. Am I making sense? This benzene is a conical structure. This is the conical structure of benzene. Do you understand? But if you see something like this means one of the carbon group is still an adjacent of 2 hydrogen groups. That is why they are what we call delocalized. Am I making sense? So the ring structure there must be delocalized. They are condensed. In which this is like this. So this is an example of aliphatic. But this one now is only one carbon group attached with one hydrogen group, which makes it a what? An aromatic compound there. So but this one is an aliphatic because this one has a what? A delocalized. While this one is non-localized. Delocalized means it is exceeding by the adjacent there. So, am I making sense? So you have to put something on your brain. Listen, you're not here to start writing notes. I'm here to explain. I'm here to advance more knowledge to students. So you have to jot it down. Let's move. Now, we move again. Now, another one is toluene. Toluene is an old name. When you hear toluene means methylbenzene. But we did not identify if it is 1 methylbenzene, 2 methyl, 3 methyl, or 4 methylbenzene. When you say toluene combines both the 1 methyl, 2 methyl, 3 methyl, and 4 methyl. It is only when we enter into the IUPAC nomenclature of organic compound that is when we detail on it. I'm not communicating now. So when we detail on it, we only enter deep into what we call the IUPAC nomenclature of organic compounds. So we are not going to. Another one is toluene. Toluene now indicates that like this, the same pattern, but putting what? A CH3 group. The same thing, but putting a CH group. That is toluene, that is methylbenzene, like this. Then you can now attach something like this, CH3. This is called methylbenzene. This is in 1 methylbenzene, but we call them toluene. Now, another one is phenol, which is what? Something. OH group. Now, this is all. Now, watch. Let me implement some knowledge now. Now, in inorganic chemistry, we call this hydroxy group. But in an organic compound, we assume that this is an all group like this because it's an alkanol. So it's an alkanol group. So we don't pronounce this as this is called benz. In other this is called benz 1. That is benz 1 all like this. But we call them phenol because we don't know the chains, the carbon chains it belongs to. So jot it down. Let's proceed with the organic reactions that are involved in organic chemistry. Thank you.